Hello everyone, welcome to this video. In this video, we shall see question from June 2013 consisting of 3 marks. The question says, we need to find the general solution of the differential equation d2y by dx2 plus y is equal to f of x, where x is any real number between minus infinity to infinity, and the function f is continuous, real valued on the interval minus infinity to infinity, and a, b, c and k, they all are arbitrary constants. So now we need to suggest which out of these four, right, they are the solution for this differential equation. Now this question seems to be from differential equation, but we can also solve it by using the integral equation techniques. So for that, what do? We just take one of these options and then we differentiate them, right, one by one using the so-called Leibniz rule. You know what is that? And after differentiating, we'll check whether the resultant obtained is equivalent to which this equation or not. If that is equivalent, so that would be our answer, otherwise not. So let us dig in. Let us look at the first option. First option is y of x is equal to a cos x plus b sin x plus integration from 0 to x ft sin x minus t dt. Right? So we can differentiate it. So we'll have with respect to x, so y of x become y dash x. The derivative of cos x is minus sin x. So here we have this term. And then the derivative of sin x, that is cos x, so we have this term, and here we'll have to apply the Leibniz rule, this one. So firstly, we'll write the integration from 0 to x as such, right? Then we'll take the partial derivative of this term, partial derivative with respect to x of this term. Now f of t doesn't contain x, so it comes as it is. Sin of x minus t would be cos of x minus t, and then the derivative of x minus t would simply be 1, right? So we have this term, and then plus the derivative of upper limit. What is the upper limit? It is equal to x. So derivative of x with respect to x, that is 1 into this whole term where we replace t with the upper limit x. So it would be f of x sine of x minus x, and sine of x minus x is 0, so this whole term becomes 0, right? So we can differentiate again to form the second order differential equation. It would be y double dash x, right? The derivative of sin x would be simply cos x minus sin x, right? And the integration from 0 to x. Now the derivative of this term with respect to x, it would be ft as such. Derivative of cos x minus t would be minus sin x minus t, and then derivative of upper limit with respect to x, that would be 1 into f of x into cos of x minus 0. The derivative of lower limit with respect to x being a constant, it is 0. So this term is 0, and this term was already 0, right? So ultimately, can you see, if we take minus common from here, this whole term is nothing but y of x from here. So we replace this whole term by y of x, and cos of 0, that is 1. So we are only left with f of x. So this is our differential equation formed from the integral equation. And let's look at our differential equation here. So this was the differential equation. It exactly matches with that given in question. Therefore, this option is correct. So now as this was single correct option, so you are done. So, but for the sake of completeness, let us look at other options also. So let us look at second option. In a similar way, we can differentiate this equation also. Y of x would be y dash x, cos of x plus k would be minus sin x plus k is constant. So applying chain rule, derivative would only be 1 multiplied by 1, right? Plus c as such, integration from 0 to x, the derivative of this term with respect to x, so it would be this, and plus the derivative of upper limit, c into derivative of upper limit, that would be 1, and this whole term replacing t with x, so we have this term. Now sine of 0 is 0, so this term becomes 0. Again differentiate them. we'll have y double dash x, and it would be minus cos x plus k, right? And it would be the derivative of this term with respect to x, so ft, and minus sin x minus t dt, and then the derivative of this upper limit with respect to x, so it would just be c into 1 into f of x into cos of x minus x, cos of x minus x, this is equal to 1. So this term becomes c f x, and when you look at this term, this is nothing but y minus y of x, right, from this equation. Therefore we have this, but obviously there's a difference in these because there is a constant c coming over here, so this cannot be the option, right? Let us look at the third option. Third option says y of x is equal to a cos x plus b sin x is equal to integration from 0 to x f of x minus t sin t dt. So now when we differentiate this, we'll have y dash x, right, minus a sin x, no problem in that. It would be b cos x plus integration from 0 to x. Now the partial derivative of this term with respect to x, sin t being constant as such, dt as such, the derivative of this f x minus t. Now f is not known to us, therefore we have to write it like this. Then we'll perform the derivative of this upper limit, that would be 1, and we'll replace t with the upper limit x, so it would be f x minus x into sin x minus the derivative of this lower limit. The derivative of 0 with respect to x is 0, so we have this. We can again differentiate. We have y double dash x is equal to minus a cos x minus b sin x plus integration 0 to x. Now the derivative with respect to x of this term, sin t is constant as such, dt is constant as such, the derivative of this with respect to x partially gives second derivative of x with respect to x, and then we'll put the limit over here. The derivative of x is 1, so it is 1 into here d by dx of f of x minus x into sin x, and we do not know what is the value of f of 0, so we'll write it as such, right? And minus 0 because the lower limit is a constant. Now the derivative of this term, here f of 0, it is a constant, but we do not know what is its value, therefore its derivative would be simply the derivative of sin x, that would be cos x. So we have this term. Obviously this is not equal to the given differential equation, so this cannot be the solution. Option 3 is discarded. Let us look at option number D, the last option. So yx is given to be a cos x plus b sin x plus integration from 0 to x f of x plus t cos t dt. We can differentiate this. Y dash x is equal to minus a sin x plus b cos x, right? No problem in that. And then again integration from 0 to x, the derivative of this term with respect to x, that would be this, because cos t is it does not depend on x, so it will come as such, right? And then we'll perform the derivative of upper limit, that would be 1 multiplied by this whole term, where we'll replace t with x, so it would be f2x cos x, and the derivative of lower limit, that is constant, so it is 0. So we can again perform second derivative. It would be y double dash x is equal to minus a cos x b minus b sin x, then integration from 0 to x, the second derivative now with respect to this term, and then we'll put the limits. Del f by del x of f of x plus x, that would be 2x, and cos of x plus, actually here it would be minus 0, right, because the lower limit is 0, and then we'll perform the differentiation of this term. Now both terms depends on x, therefore firstly we'll perform the derivative of f with respect to x, so it would be 2f dash 2x and cos x as such, then f2x as such, the derivative of cos is minus sin x. So clearly this also does not match with the given differential equation, so the only correct option is, in this case, is option number A. So this was a pretty simple question. I hope you understood this. Thank you for watching.